And I'm not going to be able to do a lot in the next 15 minutes, but at least I would like to talk about anti-differentiation. It's a mouthful, isn't it? Anti-differentiation. What does it mean? Okay. We're interested in given f prime of x, the derivative, right? This is the derivative. The derivative of function f of x. So given this one, find f of x. So this is very unusual, right? Because the entire semester so far, we were given f of x, and we were asked to find f prime. But look at this. Now they are giving us the derivative, like for example, they are giving us the velocity, and they want us to find the distance function. So I have the velocity, and then I'm asked to go backwards and find the distance function. So this is the process of anti-differentiation. Undo the derivative, if you want, and get the function. So here is one rule that we'd like to discuss. If I'm given x to the third, you already told me today, at least once, the derivative of this is 3x squared. But now I would like to go backwards and say, given x squared, for example, find the function, and in parentheses I'm going to write family of functions, that have f prime of x, x squared. So this is what we are trying to do now. So let's say I'm given x squared, which is a derivative, and I'm asked to find the function whose derivative is x squared, and there may be more than one. That's why I put here family of functions, maybe more than one function whose derivative is x squared. So to reverse the process, here is the rule for power. X to the nth plus 1 over n plus 1. Okay, what is all this? So if I want to get x to the second power, I will have to differentiate according to this rule, where n is 2. So it will be x to 2 plus 1 divided by 2 plus 1. It's guaranteed that x cubed over 3 prime is x squared. How do I know? Bring down 3, simplifies, subtract 1 from the power, and I get x squared. So the derivative here will be 3x squared divided by 3, which is x squared. So this... Now, is this the only function whose derivative is x squared? No. The most general antiderivative of x squared is a function denoted by uppercase f of x, and that is x to the third power divided by 3 plus a constant c. How come? Since f prime of x equals x squared. How do I know? Bring 3 down, subtract, simplify, subtract 1 from the power, get x squared. And when I differentiate c, what do I get? C being a constant, of course. any constant, any real number. When I differentiate that, what do I get?
0.
That's it. So I may be asked two different things. I'm not going to use the integral symbol in this section. No, we are not there yet. So this section uses the integral symbol. I disagree. So we're not there yet. So I will explain what it means, but not at this point. So let's suppose I have a function like f of x equals 5x squared plus 3x minus 7. And I am asked to find the most general antiderivative of f of x. The notation must be uppercase f of x. By convention, that's the notation. Okay. So I have the 5x squared. So 5 stays. I multiply by x increasing the power and dividing by that number plus 3 increasing by 1 and dividing by that number, x increasing the power by 1 and dividing by that number, and then minus, what function prime is 7? Can anyone give us an idea? We'll give it a shot. I know this is new. I don't expect perfect answers at all. What function will I differentiate to get 7?
7x.
That's it. Plus a constant c. This is it. Yes, I will rearrange it a little bit. I will not write it like this. I will write 5/3 times x squared plus 3/2 times x squared minus 7x plus c. And I'm going to write it one more time. But this is the most general antiderivative of the given function. So f of x, 5/3 x cubed plus 3/2 x squared minus 7x and plus c. However, this problem is also giving us a condition. Says, now find the exact, I should say maybe only, function that fulfills the condition f of 0 is 9. Why do you think this information is given here? I found the most general antiderivative, which is a family of functions. All these functions have the same derivative. Any c, infinitely many c's. When you differentiate this, you will always get that. But now they're saying find the one, the only one that fulfills the given condition f of 0 equals 9. Why is this condition given? And what do I do with it? And what am I trying to find? Because it says find the. Yes, sorry.
This would be to find c, right?
Exactly. This is to find the constant c that will give a unique, just one, unique function. Not a family of functions. Yes. So when I plug in 0, 0, 0, 0, so what do I get for C?
9.
Very good. So now I would say, not uppercase f, but just a function, 5/3 x cubed plus 3/2 x squared minus 7x plus 9. This is the unique, the only one that fulfills the given condition. So if I'm given the velocity, I can find the distance. If I'm given the acceleration, I can find the velocity. So we were able to undo the process of differentiation and go back. So for example, and I'll stop right after this, 62 on page 379, we are given c prime of x, which is the cost, the marginal cost it's called, because it's the derivative, marginal cost. They want us to find total cost. And they're giving us 0,6500. Why are they giving us this point? Are they asking us to find the most general cost function or the cost function that fulfills the given condition? Exactly. So what would you say about the total cost? What function prime is x cubed?
3x to the fourth.
So x to the fourth over 4. Let's try again. 4 in front simplified, x cubed. So we increase the power by 1 and we divide by that specific result. Minus. Which function prime is x?
That one's x squared over 2.
That's it. And I have to write plus a constant c. But what is the constant equal to if I'm told 0,6500? 0, 0, how much is this? I'm sorry, let me not use c so it's not confused with that. A constant d. So then how much will d be for sure?
6,500.
That's it. Excellent. So the total cost function is x to the fourth over 4 minus x squared over 2 plus 6,500. And that is it.